In this video, the Protection Audit tool is used to revise the protection settings of the implemented relays. The different tool options are explained and the tripping times will be analyzed. The study case protection should be activated to initiate this application example. Let us first have a look at the implemented protection devices. The grid is divided into 4 zones and every zone has its own relay type. If we color the network model according to secondary equipment and choose the relays option, we may see that every line is protected by 2 distance protection devices. The detailed substation graphic includes a graphical representation of the implemented relays and the measurement devices. Every relay is already fully operational. Their zone reaches are calculated according to the cumulative method and the starting units are set to overcurrent except the REL670 device, which only has an impedance starting. The main task now is to evaluate the protection in case of different fault types. In order to achieve this aim, we can use the Protection Audit tool in the Protection toolbar. Change the toolbar to Protection and Arc Flash Analysis and select the Protection Audit tool. Here we can select the area where the short circuits are going to be calculated, the short circuit command to be used and the various fault types to be examined. In this case we examine 4 different fault types. Note that the single-phase fault is calculated with and without a fault resistance of 10 ohms whilst the other 2 faults are only considered without fault resistance. We want the short circuits to be calculated on all branches with a step size of 10%. If we execute this command, short circuits are calculated on every branch in the network and the relay tripping times as well as fault clearing times are stored in the result file. To analyze the results, the Protection Audit report has to be selected from the main toolbar. Here we have 3 different evaluation options: device coordination, tripping times and fault clearing time. We are going to take a look at the tripping times oriented towards the network elements. The results can also be oriented towards protection devices. In the next step we have to specify the report requirements in more detail. Let us go to the tripping times page. Here the time limits for primary, secondary and tertiary protection may be set as well as the severity category to apply in the case of corresponding failures. In this simple case, we only want to establish whether the primary protection tripping time is below or above 0.5 seconds. For this reason the severity for backup protection parameter is set to no issue. The report shows a colored bar for every fault type and protected element. If the tripping time from the detected primary protection device is above 0.5 seconds, a portion of the bar corresponding with the location on the line at which the fault was applied, is colored red. As an example, let us take a look at the single-phase fault for the line NWL2. After expanding the single-phase fault, the single-phase faults with and without fault impedance are shown. When considering faults with 10 ohm fault impedance on line NWL2, there are tripping times above 0.5 seconds. Open the detailed view of this bar and filter the row column to show only primary devices. For this line, both protection devices trip in 5 seconds when a fault is applied at the remote end. Now we have identified a critical case and have to take a closer look into the network. Mark one device in the graphic and let us look at the relays RX plot. When we calculate the same fault on the remote end of the relay, we can see in the RX plot that the resistive zone reach is too short and the zone settings should be adapted. In the same manner, the device coordination and fault clearing times can be evaluated. The Protection Audit tool is suitable for a comprehensive network-wide evaluation of all protection methods and not only for distance protection as demonstrated in this case.